In this podcast, we are going to be discussing the applications of trigonometry in sound waves. What is a sound wave? A sound wave is the pattern of disturbance caused by the movement of energy traveling through a medium. In this case, sound waves cause vibrations such as a ringing telephone or the changing of pitch in the voice. The sound or disturbance creates a wave-looking pattern and it carries the sound. Today we will be talking about sound waves in music and how it relates to trigonometry. Sound waves are a mixture of sine waves. A sine wave repeats itself after one period, which is 2 pi. But with music, the pitch changes throughout the song, therefore it will not be repeated by itself.
Engineers that build concert halls use trigonometric functions like sine and cosine to find out the angles of the sound waves and how to maximize the quality of the sound being produced inside the concert hall. Volume. The volume is the loudness of a sound and can be determined through the amplitude. The amplitude is the maximum extent of a vibration or oscillation measured from the position of equilibrium. The amplitude is the distance between the center x-axis of the graph and the graph's maximum or minimum. Trigonometry can be used to determine the pitch and the loudness of the sound. If the note has a higher pitch, then it will have a narrower sine wave. If the note has a lower pitch, it will have a wider sine wave. We can see this in the diagram displayed where the lower pitch has a significantly wider sine wave compared to the diagram on the bottom right, which has a narrower sine wave. The quieter the sound wave, the smaller the amplitude that the sine wave has. When the sound is louder, it will be displayed as having a larger amplitude on the sine graph. This is displayed in the first two diagrams that are shown right now.
In this section, I'm going to show you how to change your voice with math. Voice is made up from sound waves, and sound waves are nothing but sine graphs that vary constantly. The reason it's a cos graph is because the very first millisecond the sound waves generated, it always starts with y is equals to 0. So start from nothingness, and then it goes up and down, up and down, and goes on. If it's a cos graph, then it will start at 1 and then goes down and then go up and down, which doesn't make sense because you cannot start having something already there. As I'm speaking to the microphone right now, the software generates all the sound waves that corresponds to my voice. So that's how my voice actually looks like in sound waves. Over here is a short recording of a short phrase that for the purpose of demonstration over here. Let's hear it first, okay? Change the volume a bit up. Okay.
Hey everyone.
So that's how it sounds like, the original piece sounds like. What I'm gonna do with this is I'm gonna change to make it sounds lower than my actual recording. Okay, so I'm gonna go to change pitch. I'm gonna look at this part right here. So the frequency is it's gonna be from 43, and I'm gonna decrease the frequency here. Higher frequency means higher pitch, and lower frequency means lower pitch, which means lower voice. So I'm gonna decrease that. Okay. There's this equation. It says, okay, so if you know the frequency, you know the wave speed, you can actually calculate the wavelength. So if something divides by 1, the value is going to be large, right? So if f is really high number, say 1000, then the value is going to get smaller and smaller. So the wavelength is going to get really small like that. Really, the wavelength right here, right? It's going to be compacted and make it really small, okay? So I'm going to change that. I'm gonna change from high frequency to low frequency to change my voice. I click OK. So as you can see, okay, let's hear it first. So that's how my voice actually changed already, and you can see that the waves actually get larger, and the overall length has increased. And that is how you can change your voice with Maths.